Okay, good afternoon, everybody. Today I have one of our B1 students who is going to be doing his presentation. Today we are going to do something different. He is going to do a presentation, okay? And he is going to tell us everything about laws of thermodynamics. So, Eric, please first introduce yourself.
Hi everyone. Good afternoon, teacher. I am Erick, and here's a brief introduction of thermodynamic laws of thermodynamics.
Okay, now to start with, Eric, please tell me how many laws are there?
Usually it says that there are 3 laws. However, there are another law is considered the zero law. It's a little what's that?
It's a little different from the
Trivial?
others.
Yes, I know it's a trivial law.
Okay,
But it's considered
excellent. So please, Eric, start with your presentation.
Okay. Laws of thermodynamics, the fundamental laws, and the zero law of thermodynamics. When we talk about thermodynamics and the particular element of set or of elements we are interested in, which could be something as small as a cell or as large as an ecosystem, is called a system. And why everything that is not included in the system we have defined is called surroundings. And the flask, the Erlenmeyer inside the box correspond to the system. To the box is the surroundings, and both together form the universe. The zero log is considered consists on the if a system is in equilibrium with B system. If A system is in equilibrium with C system, consider that all systems have the different pressure and temperature defined with a volume constant. So B system is in equilibrium with C system. The first law of thermodynamics thinks big. It refers to the total amount of energy in the universe, and in particular states that his total amount does not change. In other words, the first law of thermodynamics says that the energy can neither be created nor destroyed. It only can be changed or transferred from the one object to another. Light bulbs can transfer electrical energy into light energy. One billiard ball hits another, which transfer kinetic energy and causes to the second ball to move. And the chemical energy, like food, is converted to the kinetic energy, and light energy is converted to chemical energy due to the photosynthesis. And the second law, if energy is never created or destroyed, that means that the energy can simply be recycled over and over again, right? Also, the head can indeed do work under the right circumstances. It can never be converted into the another types of energy with 10% efficiency. So every time an energy transfer occurs, some amount of useful energy moves from the useful to the useless energy category. The systems will tend to move towards this more disordered configuration simple because it is statistical more likely that the configuration of separates temperatures. In this case, for example, the heat produced by carbon, the heat it is not it's not not is used completely for to transfer the water into steam. A lot of a little amount of heat could be transferred to the surrounding and not to the systems. And there are lost energy in the way in the pipelines to transfer the vapor and the vapor to the one point to another point. The frictions could be responsible to a loss a little of energy. And third law, it's also known as Nernst's postulate. That is law states that the entropy of the system, a system taken to absolute zero, is a definite constant. Upon reaching absolute zero is 2000. It's minus 2073.50 Celsius degrees or 0 Kelvin. Upon reaching absolute zero, 0 Kelvin, the processes of physical system stops. And upon reaching absolute zero, 0 Kelvin, the entropy will possess a constant minimum value. Also, it is difficult to reach a temperature close to the so-called absolute zero on a daily basis. This principle can be exemplified by what happens in our bridge. And the meat and food we deposit will be brought to be very low temperatures, to slow down and ever practically stop the biochemical processes inside, delaying their decomposition and maximizing their useful life. And the entropy of a system approach a constant value as a temperature approach absolute zero in the different material states, like gas, liquid, and solids. The entropy is different in each one. The solid is the least have the least entropy. Liquid have higher than solid entropy, and the gaseous have a large entropy, considering another two. Thanks.
Okay, Erick, why did you choose this topic?
Because it's a topic that I received in the university and like it.
You studied this topic in university, and how long ago did you graduate?
Sorry?
When did you graduate?
I graduated 2 months ago.
Okay, and what are you planning to do now?
I am planning to study a master in Hungary or German or Mexico, if it's possible, or looking for a job here.
Okay, that's very interesting. So I wish you luck, Erick. I hope everything goes very well with you. And thank you so much for your presentation. And I will see you soon.
Thank you.